I am from KR. My name is Jae-Cheul Park. I'm a principal researcher. Today, my presentation is titled Artificial Intelligence-Based Fault Diagnosis and Prediction Technology for Machinery Systems. This is the content of my presentation. First, I will explain about mass technology development project in Korea, which is led by the Korean government, and I will briefly explain about CBM technology that is being developed at KR. Lastly, I would like to explain about possible digital services based on the CBM technology. As you might all know, from the 1960s till now, ships have evolved, centered around the efforts to enhance the stability and safety of cargo and other technologies. Economic value and operational efficiency have become the important factors in ship's evolution. And now we are discussing the development of two types of ships, autonomous ship and unmanned ship. One is a semi-automated ship, the other is fully automated ship. And these are one of the main issues in the shipbuilding and maritime industry. And these technologies can solve many problems, including the environmental issues. So a lot of researches have been conducted. And these are technological classification consisting of mass. It consists of operation, navigation part, and information processing systems. It also consists of data analysis and data acquisition system to ensure safety of the vessel. In order to enable automated navigation of the vessel, we have to collect various data sets and we have to make accurate prediction and diagnosis of the status of the vessels. These will be the basis for the maritime autonomous surface ship development. And along with our efforts for developing mass, we have to establish the logistics and infrastructure system for ports because we have to enable efficient communication between ships and the port. Mass should be operated properly and should exert all the functionalities. And this requires smart port. So in Korea, smart port, smart communication, and smart communication are being developed. And it also includes technologies that deals with smart logistics and optimization of safety and efficiency. There are various element technologies included here, 3D around view technologies, and as Dr. Kim said, it includes automated mooring system, risk detection, and operation control system as well. MAS and smart port need to be connected to each other, and for this purpose, technologies are being developed. When such technologies are fully developed, then we will be able to ensure efficient operation and safety of autonomous ships based on PSC inspection support and berthing and mooring support, as well as loading and unloading support systems. Once we develop all these technologies, then we will also have to work on digital twin technology development. KR has been building small electric fuel-based vehicles, and we are studying on the digital twin technology. We're trying to represent all the objects and physical elements we see in math into the digital arena. Also, we have to do the technology development in accordance with the regulations of the IMO. And smart port technologies also require standardization. KR is also working on such technology standardization activities. Next is our current status of developing AI-based CBM technology. This is the overview of the project. The Korean government is sponsoring this project. We are developing mass autonomous ship-related technologies. One of them is CBM technology. We have to first of all understand CBM. CBM is to collect real-time data and analyze the data to diagnose any problems with the system and make prediction about the possible fault that could occur in the engine system of the vessel. And we have to use early detection technologies to optimize the maintenance activities. This is the framework of the CBM technology. First, we have to collect and store data, and we have to pre-process the data and come up with the results that will help us in our diagnostics and prognostics activities. Once we verify the results, we can set a plan for maintenance. For development of CBM, we selected some equipment, which includes main engine and generator engine, and pump and purifiers, as well as piping system. These 5 categories of equipment are the basic elements based on which we're developing CBM technologies. And remote maintenance technology is also being developed, but today I am going to skip that part due to time constraints. Anyhow, the CBM and fuel safety technologies have to be developed along with each other, because once a code on CBM technologies is enacted, then we have to work on we have to ensure safety of the vessels. And the two technologies are closely related to each other. This is the consortium of the technology development project. When we first developed CBM technologies, we installed the monitoring system on the vessel. It should generate data, and once we collect and store data, we thought that we could get a valuable insight from the data. But if we don't have the fault mode data, it's difficult to develop the algorithm. So in the main ship, we established a land-based test bed, and we arbitrarily caused an error and used that fault mode data. This is the process we went through. For this kind of testing, we have to analyze what kind of error we're going to create, and we have to set criteria over the specific type of fault, and then we have to create the fault mode scenario. We have to develop the test methodologies. These are what we did before. After producing the relevant data, we have to apply this to our algorithm. So we had to analyze the reliability of the data. This slide shows the actual fault mode data, and under the fault scenario, we operated the systems and we reassembled the equipment as well. So the test went on for about 5 hours. As mentioned before, not just engine and generator, but also pump and purifiers went through the testings. And we established a test bed, and under the same research framework, we developed the scenario, we generated the test data, and conducted simulation as well. And Mukpo Maritime, Ocean and Maritime University worked with us. We represented the damage on the vessel through the scenario and analyzed the relevant data. After data analysis is completed, we can have the data framework where we can use the data diagnosis algorithm. We extracted the data feature, as you see here. The data generated through the research process, including vibration data, internal pressure data, and temperature, and many other operational data were collected and analyzed. And our server would be overloaded with such a huge amount of data if we have to apply all the data. So we extracted important features of the data and analyzed the data and apply them to algorithm. We collected the time series data and converted the data to recurrence plots and developed the algorithm. Regarding internal combustion engine, we used our source data, and the algorithm performance showed about 95% accuracy. In the case of the pump and auxiliary systems, we also developed a diagnosis algorithm based on machine learning. Its performance level is over 95%. The same goes true for pipes. Various imaging, temperature information, and electrical resistance information and corrosion-related information were collected and measured and analyzed. And based on such data information, we developed the diagnosis algorithm. And performance of the algorithm is also around 95%. For this one, we finished the testing. And next year, in February next year, the demonstration vessels will be delivered, and we need to ensure the performance of the system on the real vessel. At first, at lab level, we use the algorithm and based on the data, error data that we arbitrarily generated, but from next year, we're going to use Polaris vessels and Hannara vessel as a way of demonstrating the CBM system algorithm that we developed. This is the software architecture, which shows what kind of systems will be composed. We collect VMS or AMS data, process the data, and send the data to the server and let it be analyzed, and then use the data analysis for decision-making process. So CBM system should work perfectly even when connectivity is not offered. We have to be able to send the CBM system data to the landside systems as well. This is based on the DevOps concept. This is the current status of dashboard development. This dashboard is installed in the main demonstration vessel. This is the slide that shows various sensors and systems installed on the vessel named Hannara. And we installed various sensors. Although we have to discuss the efficacy or effectiveness of this idea, as you see, this is the system installed in the test vessel from Korea Ocean and Maritime University. We are optimizing the test systems by reflecting the feedback from operators, and we are continuously improving the diagnosis algorithm. Our KISC center receives the data, and we are establishing an infrastructure to optimize CPM system. We are going to enhance the survey or inspection service we provide to the stakeholders. Our future plan. We will continuously receive feedbacks regarding what we developed, and we will make continuous improvement. In February next year, the demonstration vessel will be delivered, and we are going to reflect the feedbacks we received from the relevant stakeholders in the demonstration vessel. And one of the mainstream activities of KR is inspection. Considering this, I would like to explain about possible digital services. Remote inspection or extension of inspection cycle will become possible. So we are trying to establish the technical infrastructure as well. We have to refer to the IMO or IAX regulation. In terms of technology, we are conducting AI convergence research activities to develop digital service inspection method. These are the purposes of our digital service. We would like to enable long-term partnerships, and we would like to make it possible to provide remote diagnosis services through our technology. For consulting services, we need the efforts from all interested parties in the industry, including the Register, Korean Register, and many other participants of this industry. Regarding the remote and automated inspection technology, we need the joint efforts of all interested parties. As you see here, manufacturers and machine learning domains, as well as class societies, need to maintain their organic relationship with each other, and they need to be able to help each other and have accurate understanding about the status of the business. Although they could have separate business models, but they need to have consistent voice regarding the technologies. And we're trying to digitalize the inspection service we provide. So we are studying very hard to come up with ideas for digital services based on the CBM diagnosis system.